Algorithms. It's a more controversial word in mathematics and computer science world. Okay, fine. Here I just picked up some random numbers. Just have a look at these numbers. Take your own time and find the biggest number from this list. So you might identify that 9 is the bigger one from this list of numbers, correct? Okay, now go back and just think slowly what you did to find the biggest number from this list. You started looking at this first number and then you have moved to second number, and you might compare the second number with the first one, and your mind stores that 4 is the biggest number for now. And then again your eyes has moved to next number and compare this with the number which you already memorized as the bigger one, that is 4. Since next number is less than 4, your mind keeps 4 as the biggest number. Again for the next number, still 4 is the biggest number. And again next number, it's 9. So your mind automatically registers that 9 is the bigger number now by comparing with 4. And you would move to next number. It's not greater than 9. So you kept 9 as the bigger one. And then last number. Again, no. So you declared 9 as the bigger number from this list. This is how you identify 9 as the bigger number from this list, right? You know what you did now? You have just used some procedure to identify the bigger number, right? This is what algorithm is. Algorithm means well-defined procedure to implement something. There may be a lot of ways to implement the specific problem, but algorithm is the efficient way to do that. Or simply we can say that an algorithm takes a value or set of value as input and produce the value or set of value as the output. So algorithm is thus a sequence of steps that transform input into the output. To understand this and more clear, we will take an example. Let us consider the problem of preparing an omelette. To prepare an omelette, we have to follow some steps. First, we have to get the frying pan. And then the second step is we have to get the oil. Here we have to check whether do we have oil or not. If we have oil, we have to put it in a frying pan. If no, there we have to decide do we need to buy oil or not. If yes, then we have to go on buy. If no, we have to terminate the process. Once we have the frying pan and we have oil, then we have to turn on the stove and do the cooking. That's it, right? Here what we are doing, we are providing a step-by-step procedure to make an omelette. It's algorithm for preparing an omelette. So algorithm is step-by-step instructions working quietly behind the scene. We can also view an algorithm as a tool for solving a well-specified problem. Again, I am highlighting that algorithm means well-defined procedure for the implementation. In real time, for the specific problem, we might have lot of options to choose from the algorithms. It's very important to analyze the algorithm and choose the right one for our problem statement. For example, if you want to go from city A to city B, there can be many ways to go. For example, by flight, by bus, by train, and also by bicycle. Depends on the availability and convenience, we have to choose the one which is suitable for us. Similarly, in computer science, multiple algorithms are available for solving the same problem. Say for example, a sorting problem has many algorithms like insertion sort, selection sort, quick sort, and many more. It's our responsibility to choose the right one. Analysis the algorithm helps us to determine which algorithm is most efficient in terms of time and space consumed.